In this class, we are going to discuss Cauchy's theorem for multiply connected region. So, suppose we have a multiply connected region bounded by two curves C1 and C2. So, in individual curves C1 and C2, we take the direction of integration as anti-clockwise. So, this is C1, this is C2. Now suppose our function f of z is analytic in this region, in this multiply connected region. Then Cauchy's integral theorem says that integral over c1 fz dz is equal to integral over c2 fz dz. So please note that both c1 and c2 are taken in anti-clockwise direction, and f of z is analytic in the multiply connected region with these two curves as bounding curves. Then integral over c1 fz dz is equal to integral over c2 fz dz. So if you reverse the direction of c2, that is, if you take c1 in anti-clockwise direction and c2 in clockwise direction, so this will be minus c2, right? If this is c2, this will be minus c2. So if you take it, you can write integral over c1 fz dz. Taking this to the left side, integral over minus integral over c2 fz dz will be equal to 0. And integral over minus integral over c2 is equal to integral over minus c2. So integral over minus c2 fz dz will be equal to 0. So if one curve is in clockwise direction and the other is in anti-clockwise direction, when you add the integral along those two curves, you will get it as 0, provided our function is analytic in this region. Now the same result can be extended to Cauchy's integral formula. That is, addition to these conditions, that is, we have a multiply connected region bounded by two curves C1 and C2 taken in anti-clockwise direction. F of z is analytic in this annular region, and along with this we have a point A that lies in this multiply connected region. Then we can write integral over c1 fz dz fz by z minus a dz plus integral over c2 fz by z minus a dz. Integral over minus c2 fz by z minus a dz will be equal to 2 pi I into f of a. So remember, we take one curve in clockwise direction, the other curve in anti-clockwise direction. The integral will be equal to 2 pi I into f of a. And you can extend this to derivative of analytic functions, that is integral over c1 fz by z minus a the whole raised to n plus 1 dz plus integral over minus c2 fz by z minus a the whole raised to n plus 1 dz, that will be equal to 2 pi I by n factorial, the nth derivative of f at a. So these are the results for multiply connected region. Now let us see this. Evaluate integral over c e raised to z by z dz, where c is the contour mod z equal to 2 counterclockwise, and mod z is equal to 1 clockwise. So when you consider C consists of two circles. One is mod z equal to 2, and mod z equal to 2 is taken in counterclockwise direction. Let us name this as C1, and mod z equal to 1, that is taken in clockwise direction, C2. So see here our C is C1 plus C2. It's a combination of these two. So see here already one is in clockwise and the other is in anti-clockwise direction. And hence we can say integral over C1 e raised to z by z dz plus integral over C2. ഇവിടെ നമ്മൾ റിവേഴ്സ് ചെയ്യേണ്ട കാര്യമില്ല കാരണം ഓൾറെഡി അത് ആന്റി ക്ലോക്ക് വൈസ് ഡയറക്ഷനിലാണ് തന്നിരിക്കുന്നത്. സോ ഔട്ടർ കർവ് ഇൻ ക്ലോക്ക് വൈസ്, ഇന്നർ കർവ് ഇൻ ആന്റി ക്ലോക്ക് വൈസ്, ഇത്രയും നോക്കിയാൽ മതി. ഇപ്പൊ ഇന്നർ കർവ് ക്ലോക്ക് വൈസ് തന്നിരിക്കുന്നതെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇവിടെ അതിന്റെ നെഗറ്റീവ് എടുക്കണം. സോ ഇത് ഓൾറെഡി ആന്റി ക്ലോക്ക് വൈസ് ആണ്. സോ ഇന്റഗ്രൽ ഓവർ C2 e raised to z by z dz, and we have to make sure that the function in the numerator is analytic in this region, and e raised to z being an entire function, it is analytic everywhere. That's why we proceed to find this, and z is equal to z is equal to 0 is not a point in this region. ഇതാണ് നമ്മുടെ region, right? അപ്പോൾ ഡിനോമിനേറ്ററിൽ z is equal to 0 ആണ് വരുന്നത്. z is equal to 0 is outside the region. So z is equal to 0 outside the region means e raised to z divided by z is analytic in this region, right? As it is analytic, you can say integral over C1 f z e raised to z dz plus integral over C2 e raised to z dz will be equal to 0. Right? Analytic ആണെങ്കിൽ integral will be equal to 0. വീണ്ടും ഓർമ്മിപ്പിക്കുന്നു, ഒരെണ്ണം ക്ലോക്ക് വൈസും മറ്റേത് ആന്റി ക്ലോക്ക് വൈസും ആവും. രണ്ടും സെയിം ഡയറക്ഷൻ ആണെങ്കിൽ നമ്മൾ എഴുതേണ്ടത് integral over C1 e raised to z dz equal to integral over C2 e raised to z dz. So this integral is equal to 0. Now let us see one more example. Integral over C, find integral over C sin z divided by 4z square minus 8iz dz, where C consists of a square with vertices z equal to plus or minus 3, z equal to plus or minus 3i in counterclockwise direction, and square with vertices z is equal to plus or minus 1 plus or minus I in clockwise direction. So our contour is z is equal to plus or minus 3 plus or minus 3i. This square in counterclockwise direction. Let us name this as C1, and plus or minus 1 plus or minus I in clockwise direction. So as in the previous case, we check for the zeros of the denominator. So we have function as 4 into z square minus 2i z, or this is equal to 4z into z minus 2i. So the zeros are z equal to 0, z equal to 2i. Now 0 is outside this region and 2y is inside this region. Okay. So you can write f of z as sin z divided by 4z, and this function is analytic in the region. So we can write the integral as integral over c f z by z minus 2i dz, and this is equal to integral over c1 f z by z minus 2i dz plus integral over c2 f z by z minus 2i dz, and that is equal to 2 pi I into f of 2i. It is equal to 2 pi I into f of 2i is sin 2i divided by 4 into 2. So you can cancel that 2i to get I sin 2i divided by 4 as the value of this integral.